This is the 9th video of the summary on Battery Day. It covers the structural battery.
And I think it's the way that all electric cars in the future will ultimately be made. It's the right way to do things. It starts with having a single piece casting for the front body and the rear body. In order to do this, we commissioned the largest casting machine that has ever been made. And it's currently working just over the road at our Fremont plant, currently making the entire rear section of the car as a single piece, high-pressure die-cast aluminum.
Independent car expert Sandy Munro speaks very highly of Tesla's Giga Casting when he tore down a Model Y. Check out the Munro Live teardown videos on YouTube.
In order to do this, we actually had to develop our own alloy because we wanted a high-strength casting alloy that did not require coatings or heat treatment. This is a big deal for castings, especially with a large casting. If you heat treat it afterwards, it tends to deform. There was no alloy that existed that could do this, so we developed our own alloy, a special alloy of aluminum that has high strength without heat treat and is very castable. What we call it the structural battery, where the battery for the first time will have dual use. The battery will both have the use as an energy device and as structure. In the early days of aircraft, they would carry the fuel tanks as cargo. Basically worse than cargo. You had to kind of bolt them down. What if we just make the fuel tank in wing shape? Then the fuel tank serves as dual structure. It's no longer cargo. It's fundamental to the structure of the aircraft. This was a major breakthrough. We're doing the same for cars. Effectively, the non-cell portion of the battery has negative mass. It also allows us to pack the cells more densely because we do not have intermediate structure in the battery pack. Instead of having just a filler that is a flame retardant, which is currently what is in the 3NY battery packs, we have a filler that is a structural adhesive, as well as flame retardant. Basically, a honeycomb sandwich with two face sheets. We can actually use the steel shell case of the battery to transfer shear from the upper and lower face sheet, which makes for an incredibly stiff structure, even stiffer than a regular car. In fact, if this was a convertible, it would be stiffer than a regular car. It also allows us to move the cells closer to the center of the car. Because they're closer to the center, it reduces the probability of a side impact potentially contacting the cells. It also improves what's called the polar moment of inertia. Like ice skater, arms out or arms in. Arms in, you rotate faster. That means the car maneuvers better. It just feels more agile. So 10% mass reduction in the body of the car, 14% range increase, 370 fewer parts.
It is worth another 7% dollar per kilowatt hour reduction at the battery pack level, bringing our total reductions now to 56% dollars per kilowatt hour.
If you want more on the Tesla Battery Day, you can continue with the next video, or you can go to the first video that provides an overview of all the videos.